Welcome, my friends. Welcome. I am excited to begin our journey today. Hopefully you can hear me nice and clear. Now, as we begin our journey, there's a concept that we need to go over that's covered in Algebra 2, but we really kind of want to learn it for AP Calc because it helps build the foundation of calculus and something called derivatives. Now, average rate of change is rise over run, right? Something that we learn in Algebra 2, and we're going to get some practice with that. And I want you to also keep in mind that as we go through, I will give you some real world scenarios, but for now, let's just understand what we're doing with graphs and equations and etc. So let's just take a look. Let's get started right away. So let's take a look here. Let's begin by looking at linear functions first. Look at the graph below and determine the average rate of change of each graph. Well, what is the average? Well, I'm asking you, what is the rise over run? Average rate of change is just another way of saying rise over run, which is y2 minus y1 over x2 minus x1. Well, let's take a look over here. We usually like to start at our y-intercept, so I'll make a dot here and another location on this graph that I can visually see across right there. So if I was to do rise over run, well, I go up 1, 2, 3. So my average rate of change so far, rise over run, would be 3 over. And how much do I go over? Well, 1, 2, 3, 4. 3 over 4. This is my average rate of change. All right, now I can do this without having to use the formula I just provided over to the right. But let's use the formula to the right over here and let's give it a shot. So again, I like to start with the y-intercept. And I'll go ahead and maybe pick this point right over here. So these 2 points. So let's do rise over run. Well, first thing we need to do is we need to identify x1 and we need to identify y1. And over here, we need to do x2 and we got to do y2. Okay. So it doesn't really matter which point you choose, but we'll go ahead and call this x1. So let's go ahead and label this -2, comma 3. This is x1, y1, and this right here is, well, the x value is at 0, so 0, comma, -2. So we got x2, y2. Okay, and let's go ahead and insert that into here. So we got -2, 3, 0, comma, -2. And if I want to find my rise over run, well, I just do delta y over delta x is equal to, we already have the formula right up over here. So y2 minus y1, well, this is y2, so -2 minus, well, y1, which is 3, all divided by 0, x2, 0, minus, well, be careful because this is a -2, so minus -2. Maybe I'll put parentheses just to be careful. -2 minus 3 is -5. Over, well, this becomes a +2. So that means that this graph, the rise over run, my average rate of change is -5 over 2. And that makes sense because this line is negative slope. And now let's verify it. I go down 5, 1, oops. I go down 5, 1, 2, 3, 4, 5, and then I go over 2, 1, 2. There it is, my friends. So my average rate of change is going to be -5 over 2. All right, pretty cool, and that's pretty much it. Let's go take a look at one more graph here. Well, what if I ask you to find the average rate of change of this graph here? Now, without even having to do any work, I can kind of see, hey, my average rate of change should be 0. And if you're not sure why, well, let us work through it. So you can pick any 2 points to do our average rate of change, right? As long as we make sure we're consistent with our formula for average rate of change, y2 minus y1 over x2 minus x1. And if you pick any of these 2 points, we can do rise over run. Well, look on this graph. It's a straight line. You can't go up at all, right? Like you can't go up any rise. It's just a straight line. That's why it would be 0. But let's verify. So pick 2 points. I don't know. I'm reading your mind and I could see that you picked one and you can pick any of them. Here we go. I'll label this one to be the x1. Okay. And this one to be the x2. But let's just go and label it here. So my x1, comma, y1 and x2 comma y2. So my x1, well, when it's 1, the y value is 4, and when it's 6, my y value is 4. All right, and if we go to do rise over run, well, we just proceed to use our formula. 4 minus 4 divided by 6 minus 1. And we get 0 over 5, which is in fact 0. And that's why we're going to get 0. Well, look, to get from this point to that point, we didn't go up or down at all. That's what the 0 means. And it's saying that we had to go over 5, which is still consistent. 1, 2, 3, 4, 5. But again, we didn't go up or down at all. So my average rate of change is 0. It doesn't change at all in terms of the rise. So there it is. A straight line will always have an average rate of change of 0. All right, let's take a look at these more examples here. What makes this problem different than what we did before recently? Well, look at this graph here. We have this graph that's provided to us, and we want to determine the average rate of change over this graph. Well, I want you to notice what's different here, and I drew them, and hopefully they're a little bit clear, but you'll notice right here we have brackets. These are brackets. We got brackets from -5 to 8. Now I want you to notice anytime you see brackets, that doesn't mean x1, y1, right? Because to compute average rate of change, we need 2 points. So believe it or not, this, whenever you see brackets, this means from x1 to x2. This tells me my first x value to my second x value. So what I think might be helpful to do is we need to translate them into our points here. Let's write x1, y1, x2, y2. Okay, and we'll get some practice with this. This might seem weird. So whenever you see brackets, well, this is my x1. So let's go on this graph. When my x1 right over here is -5, well, my y value is -4, so -5, -4. And this is x2, so let's write over here 8, and let's go look on the graph. Well, when it's 8, my y value is -3. So let's go over here and write -3. All right, wonderful. Now we'll just go ahead and now that we have that there, now we can write delta y over delta x, y2 minus y1 over x2 minus x1, and we proceed. -3 minus -4, right? y2 minus y1, let me put parentheses, over 8 minus -5. And we get -3 plus 4 over 8 plus 5. Okay, we do this, we get 1 over 8, 9, 10, 11, 12, 13. 1 over 13. So my average rate of change is 1 over 13. Okay, so if you look over here, here it is here's my 2 points at -5 and at 8. Doesn't make sense. Well, it says I have to go up 1, so go up 1, then I need to go over 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. And you essentially get, this is my average rate of change that crosses through those 2 points. Okay, so why don't you try this right here? You can pause the video and give it a try. I will go ahead and write the answer very quickly. Again, these are brackets. So what do we have to do? Well, let's translate them into parentheses so that I can get my x1, y1, x2, y2. And the first one tells me -2, right? And I got to go find the y value. This is my x1 and this is my x2. So now I'll go over here and put 2 there. Okay, so when it's -2, look on the graph, well, it's +2, so put +2. And when it's x value is +2, my y value is 3, so 3. There it is. Now I'll go ahead and do delta y over delta x and go ahead and do this. And if you set this up correctly, we should get 1 over 4. It should be positive, and you can verify that because it's basically going to be this right here, which goes up by 1. And if you count it, 1, 2, 3, 4 to get to there. All right, so there it is, average rate of change with graphs. Again, maybe the big thing is that whenever you see brackets, it tells you x1 to x2, and then you have to translate that into this right here so that you can organize your work to then find your average rate of change.